Hi. So in this second half of the surfacing operations, we're going to be working with optimized planes. So if we go back into the machining environment now and we set up a new 3D entry and optimized plane operation, we will be using a new tool for this. We'll be using a ball nose tool just to be able to capitalize best on the geometry of it to get clean, rounded surfaces. And we're going to have to go around and fairly painstakingly select all of the curved surfaces that we want to work with. So this will take a short while to do. So to start with, I am going to change the tool to a, we'll go with the 5mm spherical mill, and we'll increase the length. Actually, tell you what, let's do this this way instead. So that's 5, keep it at 60mm long, and click on OK and create a new tool. That's fine. We want to define the specific areas that we're going to be working with, so we're going to have to go around and grab all of these surfaces now. So let's make a start. Unfortunately, there's not a lot of interesting commentary that can be given for batch select clicking like this. So as you can see, I'm grabbing both the positive and negative curved surfaces here, just so we can get the cleanest overall transition between the two. We're not so fussed where there's just a straight down cut like that, because that could be dealt with using profiling pass. However, wherever the edges do roll in like this, I want to try and get the cleanest transitions we can for it. This is unfortunately probably the most tedious part of this job, and you will find there are plenty of jobs akin to this in your machining career. So this is just one of those unavoidable elements, I'm afraid. But to spare you the pain, I will come back to you when I've got all of these curved surfaces selected before any further in the process. So I'll catch you in a couple of minutes. Okay, so we're now back and we have selected all of the most important curved faces here. I've not necessarily bothered with ones that can be covered by a subsequent profiling job, but wherever there's any transitional faces like this, I have grabbed them. So now that we've defined these, we are going to define the job zone just so it doesn't go anywhere completely mad outside. And we are going to set the 6th axis control and then generate the toolpath and see what it comes up with. Okay, so as is expected, we've got only a partial toolpath worked out. So if we now go into the axis mapping tool and generate the map and see where the particular holdups are. Once again, we've got our now incredibly familiar 0-degree deflection issue. Again, this is a fairly well established shortcoming of using a robot for purely 3-axis milling. It's obviously not insurmountable, but it is an issue you need to be aware of when planning jobs like this. So I'm going to break this calculation now and build the graph accordingly and then update the map. And now we can see that all of these curved sections that are transitioning between either flatlands or straight drop-offs are all pretty much covered. So we have got a complaint on the node graph here. I'm going to guess that that's, again, it's a gouge, which is surprising. So we're going to turn off check for gouges for the moment, and we are going to simulate this path. So just close that window and we'll simulate this as is. It'll take a second. Due to the nature of the optimized toolpath, it'll do a series of crisp-thin cross paths. You may find yourself wondering why I've gone for an optimized toolpath instead of a complex toolpath. The reason for that is there's not really enough of a Z value in any of these component parts to warrant using a complex toolpath. Because that's a hybrid between a planar toolpath and a finishing waterline style toolpath, it really does need a bit more height variance to capitalize on it fully. Okay, so we've done this. There's a couple of small gouge markers that are in here. If we click on Verify Compare, we can take a look around the model, and there's some very, very small yellow nicks here. But as we can see, that is basically that's down to minus 0.01 of a millimeter worth of deflection. Now, obviously, that's down to you as to whether or not that is an acceptable amount within your model. For the sake of this, and I would say for just any kind of plane engine casing, if it's not on a mating part, I don't really see that as being an issue. So from this point, I'm happy to continue with the rest of the project going forward. Subsequent to this, we are going to be dealing with cleaning up all of these bores, and then we're going to do a profiling pass around all of these remaining areas, cleaning up any of these bores and these interior edges, as well as exterior profiling, and we're going to do a final planing cut on the top surface here to bring this all within tolerance. I know there's an increasing amount of red nodes appearing in here. These are all well within acceptable parameters for this though, so I shall see you in the next video.